we had gotten up to just defining what a reference angle is. What we're gonna do here, and I think you did some in the homework, but I'll just do it just to show you how I want it to be done. Okay, so to sketch and find the reference angle, to sketch an angle, right, here's what you do. You have an X and a Y axis, all right? Now, to sketch the angle, I need to see the initial side here. You see that in the purple? I need to see that initial side. And then I need to know that you're going in the positive or the negative direction as stated by the angle. So in this case, it's in the clockwise direction because it's negative 150 degrees. So here, right? And then that's the terminal side. So those three arrows are what I need to see there.
Sorry, were we getting our homework stamp today?
Afterwards, yeah. Okay, so this is negative 150 degrees, and so that's theta. For the reference angle, we say theta prime, and how much is that? 30 degrees, right? Because it's the balance between where we left off and the nearest x-axis. Okay, so when you draw this for me, you don't have to put that red arrow, just the purple one's fine, but it's that little angle, right? So I stopped at 150, 30 more would have made 180. Okay, next, 3 pi over 4. Again, x and y axis. Okay, I start here. Now this is a positive angle, so I'm going to go counterclockwise. And the way I approach the radian measures is 3 pi over 4 can be written as 3/4 of a pi, right? So that's obviously going to be more than half a pi. So here, right, 3/4 of a pi right there. Now, why is it simpler to work in radian most of the time? Because you know that if you went 3/4 of a pi, well, you just have to go another 1/4 of a pi, right? So it'll always be 1/4, right? So pi over the denominator for the reference angle, okay? So theta prime is pi over this denominator. Now, I kind of had you guys write this the other day, that the reference angle is the pi over the denominator when it's in radian. I don't know if I specified enough that the angle has to be reduced for you to do that, okay? Okay, good. Okay, so putting it all together, okay, why were we doing this? None of this that we've done so far is stuff that you'll be asked explicitly, right? In the real world, you wouldn't be asked to find a reference angle or this or that. All of this was so we can do what's coming up, and that's to evaluate trig functions of an angle, okay? So that's what we're going to talk about here. There are 3 steps to this. First, it's find the reference angle. Now we're experts on doing that. Next is evaluate the trig function for theta prime, the reference angle. And lastly, depending on where the terminal side lies, determine the sign, SIGN sign, positive or negative, of the function. And how do we do that? Let's focus on number 3 for a minute. Did you guys go over all students take calculus last year? Okay, so it doesn't have to be a true statement. It just has to be a statement that works for us in math, okay? Just like, you know, PEMDAS is like, what is it? Purple eggplants make, or that one, and also purple eggplants make delicious afternoon snacks. Is that it? I mean, it doesn't have to be a true statement. It just has to.
Remind me what all students take?
I will. Okay, here's what all students take calculus means. So you've got your 4 quadrants, yes? And again, everything is always counterclockwise. So it's all students take calculus. And each of the quadrants, the letter of the function determines which of those is going to have a positive or a negative value. So here when it says all, A for all, everything is positive, sine, cosine, tangent. So if your angle, if you draw your angle and the terminal side is here, all of the functions are going to be positive. If your angle ends up here, then only sine is positive and everything else is negative. Okay? Hey guys, I love that you guys are such close friends, but let's pay attention here too, yeah? Okay. So tangent here, tangent is positive, everything else is negative. Cosine is positive here and everything else is negative. So if you've got an angle that ends up here and you want to take the tangent of it, it's positive. You want to take the cosine of it, it's negative. That's what it is. Okay, so let's do this one. Find the exact value of each expression. So first of all, 11 pi over 6, right? Yeah, question?
Wait, so yeah, so the sign is just like the y.
Uh-huh, yeah. Okay, so tangent of 11 pi over 6, okay? So first of all, let's find the reference angle. How much is theta prime? Pi over 6. Okay, now, I need to find the tangent of pi over 6, right? So let's draw it first. You can sort of do two things at the same time. 11 pi over 6 is where? Fourth quadrant here, and that's the smaller angle, right? So basically, if I want the tangent, that's the opposite over the adjacent, right? So it's y over x. So it's, how much is it? Is it root 3 or 1 over root 3? 1 over root 3. Okay, so let's figure out how we do this, okay? So if it's the opposite over the if it's the y over the x, we know that this is the small side of a half, and this is the larger side of root 3 over 2, right? So it's going to be 1/2 over root 3 over 2, 1 over root 3. Okay? Yes?
Is that like is pi over 6 45?
You tell me.
No, I'm trying to learn the units.
So pi is 180, right? Over 6, that's 30. Okay? So that's going to be 1 over root 3. Okay, so is it going to be positive or negative? Negative. Okay. Let me show you a little something else, a little secret. Don't tell anybody though, okay? Don't tell anybody. Okay, so this is the smaller angle, right? The pi over 6 is the smaller angle, so it faces the smaller side. Now, what we're doing for tangent is we want to find the ratio between that vertical and that horizontal, right? So that's going to be a small ratio, correct? Yeah? Okay, for tangent of pi over 6, pi over 3, your two options are 1 over root 3 and root 3. Okay, that's all you can get for the 60 or the 30 for tangent. Which one of those has a smaller value? 1 over root 3. So if your ratio here is going to be a small ratio, small over big, it's going to be the 1 over root 3. All right? As opposed to if you had like the bigger angle, hang on, I'll get you in a minute. If you had the bigger angle, if it was the pi over 3, right, then this is bigger than this one. So that ratio has to be greater than 1. It would be the root 3. Okay? So that's another way that you can think about it. Okay, Gabe, what was your question?
I was just gonna ask why like 1/2.
Okay, so remember yesterday we rescaled the triangles, and we said now that we rescaled the triangles and we made the hypotenuse 1, this is now 1/2 and root 3 over 2. So it's never going to be a 2 anymore. It's always going to be either a half or a root 3 over 2. Yeah.
Is tangent sine over cosine or cosine over sine?
You tell me. Sine over cosine. Okay? All right. Okay, last one, and then I got to move on. Yep.
Sorry, will you remind me, is sine x or y?
Y. Okay? All right. Okay, so secant of 270. Where is 270?
On the axis.
It's on the axis itself. So there is no reference angle for this one. Instead, we use the coordinate point. Correct. So this is 0, -1. And since it's secant, it's 1 over the cosine. This will be 1 over 0, undefined. And that's what your final answer should be, undefined, not 1 over 0. Okay? All right, let's do another one. Cosine of 9 pi over 4. Okay, let's draw that. 9 over 4 pi, that's 2 1/4, right? Yep. So I start here, I go 2 pi and another quarter. It's in the first quadrant. And it doesn't matter what I'm finding there because they're all positive. Okay. What's the reference angle? Pi over 4. So all I need is the cosine of pi over 4, which is root 2 over 2. Okay. Is everybody comfortable with how we're doing that? Okay. So sine of negative 300. All right. So negative 300, we're going to go this way. What's the reference angle? 60 or pi over 3. Good. And now if I want the sine, it's got to be, what do you think? Root 3 over 2. Okay, so let's think about that for a minute. Look, you have one of two options. If your reference angle is the pi over 3, which is the 60, it's root 3 over 2 and 1/2. Okay? If it's the 30, it's 1/2 and root 3 over 2 like this. So if you're talking about the bigger angle, faces the bigger side, and that's small. The smaller angle faces the smaller side, that's the bigger one. Okay? Okay, so 120, here, I'll do it here. 120 is right here. So look, the reference angle is the pi over 6 or the large angle, right? So automatically the triangle is going to look like this. That means the cosine, which is horizontal, is the smaller number of how much? 1/2. Negative or positive? Who says positive? Who says negative? Negative. Okay, just checking there. Okay. Okay. All right. 4 pi over 3. Who can tell me what quadrant?
Third.
Any other answers? Third. We're sure?
Yeah.
Okay. As long as you guys are sure, it's 1 pi and a third pi. So here. So now, so I went 1 pi and another third pi. So here I ended up with the larger angle, right? Okay. Sine is the larger side, root 3 over 2, and it's negative. Okay, now, you don't, like for me, you don't ever have to draw the horizontal and the vertical like I did in blue. Okay, I'm just doing that to illustrate. If you want to draw the angle like this, like if you need to, like, if you want to show work and draw the angle, you're more than welcome to. Eventually, we want to get to the point where we can look at cosine of 120 and we can figure out it's negative 1/2 without the aid of drawing and this and that, because we want to be as quick with them as possible. Okay? All right. So the way we do it is, okay, you end up with a bigger angle, root 3 over 2. So I know this is 1/2. You end up with a smaller angle, 1/2. So I know this is root 3 over 2. Okay. So secant of 15 pi over 4. Fourth quadrant? Yeah? How much? Okay, fourth quadrant. And it's pi over 4.
So root 2 over 2
So, okay, hang on. So this is like cosine, right? So here cosine is positive, so it'll be positive. Okay? And now, the cosine is 1 over root 2, yes? The reciprocal would be just root 2. Okay? Okay, any other questions? Okay, let's... Let's say that again. Okay. Okay. Okay, so use one trig value to find the other. So let's take a look at this now. We have secant of theta equals this, and you're told that sine is positive. Greater than 0 means sine is positive. Find the exact values of the remaining 5 trig values. Okay, so first of all, you have to use these two together to determine quadrant. Okay, so let's start with a mini unit circle here. Okay, so it says in the first one that secant is positive, right? If secant is positive, which one of the quadrants can it be in? If secant is positive, then so is cosine. Cosine or secant is positive here, and then also all students take calculus, it's positive here, right? Now, I'm also told sine is positive. Where is sine positive? Here and here. When you do this, it's like black magic. There's always going to be one quadrant where you're going to have 2 items show up, okay? And that's the quadrant that your answer is in. Okay, so our answer is going to be in quadrant 1. Yes?
Sorry, so are you saying that there could be like an instance where it's like a -0? Same thing?
No, greater than 0 means positive. Less than 0 means, okay, so angle is in quadrant 1. Okay, so now we need to figure out the other stuff, and we do that like we did in the quiz. Okay, so here's how we do it. Give me one more second. So remember in the quiz, we first had to draw a triangle, a right triangle. Now secant is root 21 over 3. That means the hypotenuse is root 21, and this is 3. We can find the missing side, right? 3 squared plus x squared equals root 21 squared. So x is how much? So let's see, 9 plus x squared is 21. X squared is 12. X is 2 root 3. Okay, now we're given secant. We need to find sine. What else? Cosine, tangent, and then we'll do the rest. Okay, so sine is 2 root 3 over root 21. Okay, this can actually be simplified. I've purposely chosen these numbers because this can be simplified. I know we said you can leave the roots in the denominator, but look at how you have root 3 on root 21, which can be simplified. Yeah, 2 over root 7. So here we're going to do 2 times root 3 over 21, which is 2 times 1 over root 7. So that's just 2 over root 7. All right, so you have to simplify that way. Okay, so cosine, 3 over root 21, tangent, 2 root 3 over 3. Now, let's talk about positive or negative. Because it's in the first quadrant, right, because we determined that it's in the first quadrant, they're all going to be positive. Okay? And then you can find like the other ones, right? What is it? The cosecant, and then also the cotangent. Okay?
For your cosecant, would you just use the 2 over?
Yeah, it'll just be root 7 over 2. Okay? Questions? Yeah.
Why is secant positive in quadrant 1?
It's okay, so this is telling you have an angle and the secant is positive root 21. So you're like, okay, in which quadrant can secant be positive 1? Secant is like the cosine. So wherever cosine is positive, so is secant. In quadrant 1, everything is positive. And then in quadrant 4, cosine is positive again, because it's all student take calculus. Okay? All right, go ahead and do the next one on the next page. Well, was there a question?
Yeah, I was just I didn't understand why secant is positive in first quadrant.
Secant is like cosine, right? In the first quadrant, remember it's all of them are positive.
Yeah.
Right? So that's
It
why.
was the fourth that I was confused about. The fourth quadrant. Why is it?
Because it's, hang on, Gabe,
Oh, sorry.
I'm teaching right now. All students take calculus, right?
Oh.
Yeah.
Okay.
Okay. All right. So let's go ahead and do number 6. Example 6. Okay, hang on. If you can just see it, you don't have to do anything. So what do you guys think? 30 degrees. Okay. So these can be types of questions that are going to show up on the homework. They can show up on the test and so on. Those are the more, honors type questions, right? Not just find sine of pi over 3, but really like put two things together, like go a step further. Okay? All right. Now, take a look at this one. Okay. You're told use the given values to evaluate the trig function. So you're told sine of negative theta is 5 over 9. Okay, what the heck is negative theta? Well, okay. So, if I tell you 3, what's the negative of it?
-3.
Okay, now if I tell you -7, what's the negative of it?
7.
Okay, so first of all, we established that negative something doesn't necessarily mean that it's going to end up as negative, right? Yes? So if I have negative x, depending on what x is, this could have a positive or a negative result, right? Okay, same with theta. So when you put negative in front of something, all you're saying is change the sign, correct? Okay, so let's talk about what changing the sign means. When you have a number line, changing the sign means going from the left side of 0 to the right side of 0 and vice versa, correct? Yes? Okay. When you're talking about angles, however, if I have, an angle theta, where's the negative of that angle theta? Immediately symmetrically down below. Okay? Same way, if I have, suppose this is my angle theta. Where's negative theta? Quadrant 1, symmetrically above. Okay? Now, what this is telling you is sine of negative theta is 5 over 9. What is sine of positive theta? Okay, so let's look at what happens when you switch back and forth between theta and negative theta. So here is theta here, and look, this is the sine of theta, correct? Where's the sine of negative theta? It's at the bottom, isn't it? Okay, so sine is this distance here, right? So it's basically, sine is how much you have to go to reach that point. And here it's a positive number. So from the x-axis, you go up 3, let's say, and that'll be the sine of theta, right? But if you're talking about the angle here, right? This is the sine of that blue theta. How much is it then? How does it compare? It's the same length, but here you go up to that point 3, and here it would be -3 because it's going down. Okay? So, moral of the story is, when the angle changes between the positive and the negative, the direction that you have to go vertically also changes between the positive and the negative, right? So, if sine of negative theta is 5 over 9, what's sine of positive theta? -5 over 9. Okay? So, if sine of theta is -5 over 9. And then what's cosecant of theta? Yeah. Okay, but let's talk about the cosine for a minute. Take a look here. What's the cosine of that theta? It's that black line, right? What's the cosine of the negative theta? Same black line. Does it changes? It stays the same. Okay? So if cosine of theta is like 7 over, well, it can't be 7 over 2, 7 over 9. What's cosine of negative theta? 7 over 9. Okay? It's kind of conceptual, but it's like cool at the same time. Yeah? Okay. So